that bell icon so that you don't miss any updates from us. With that, let us move to the first question. Of course, the first question will be, what are data structures? Well, data structures are the data structures are actually methods and techniques which are used to handle and store data in an organized manner. Basically, when answering this question, make sure not only to explain about all of the data structures that are present, such as linked lists, stacks, arrays, and whatnot, but make sure that you have an understanding of what data structures are. Basically, all of these data structures are used to attain a common goal, that is to either build dependency in terms of data entities, to build and manage relationships between the data entities, or to even produce meaningful connections in between data. So basically, these are the entities, methods, and techniques which are used to store data in an organized manner. Coming to question number 2. What is the difference between a file structure and a data structure? A file structure is an entity which gets stored only on the hard disk drive or only on the local storage. But then when you're talking about data structures have the ability to natively be stored both on the RAM, that is the random access memory, and the hard disk at the same time. Then coming to the second point, there are certain policies which guide the storage of data. So with respect to file structures, we have the standard file storage policies which works across based on the operating systems and how the data is supposed to be stored. But then when we work with data structures, there are customized storage policies which make the use of data structures very efficient and increases the read-write capability, where you can access it faster, read the data faster, and write it faster as well. And then coming to the third point basically talks about the compatibility when you're working with external applications. There is a low compatibility when you work with file structures because of point number 2, one being it has standard file storage policies, and the second thing being that most of the applications are basically written based on the individual unit entities whenever data is in concern. So whenever data is supposed to be stored, each individual entity of data is actually in concern when developing policies and when finding out methods to basically store them. But then with data structures, it provides a high compatibility whenever you're storing with external applications, because this unit entity that we just spoke about is basically already optimized in this particular case. That brings us to question number 3. What is a linked list? This has to be one of the questions that will surely be asked, because linked lists form a very vital aspect of data structures, and linked lists are nothing but the most used data structures in today's world, because these form very nice methodologies and these provide very nice ways the user can store and handle data, where every individual element in a linked list is called as a node, and each of these nodes form a chain-like structure whenever you connect it to other nodes. Each node will have the data present to it and a certain address associated with it. This address is used to basically access the data, and then of course the data can be changed however required. There are many types of linked lists. There are single linked lists, there's double linked list, there's circular linked list, and more. And with that, we have question number 4. Where are data structures primarily used? You can answer this question based on multiple factors. One being that you can find data structures almost everywhere around you in the world. Data structures are an integral part of almost everything with respect to information technology. Everything from numerical computation, operating system design, artificial intelligence, compiler design, all the way until statistics. Data structures pave to be one of the foundational concepts which are very much required in today's world to handle data and to find the most efficient way and the easiest way to do it. See, at the end of the day, you're converting raw data into useful information. Finding the most effective way to do that in a structured environment is where data structures shine the most. So make sure to quote at least 4 or 5 places and concepts where data structures are used, and it would of course be advantageous if you could explain on where it is used. For example, if you're talking about data structures are used in database handling, just don't state database handling. Just go on to explain 1 or 2 lines where you're stating that they are used to form entities such as linked lists. It can be stacks and queues, and these stacks and queues provide a way to have organized access to data. So make sure to elaborate a single point based on the usage that you have mentioned. Coming to question number 5. What are the types of searching methodologies used in data structures? Well, there's two main types of searching whenever you talk about data structures. It's linear search and it's binary search. Linear search, as the name suggests, is basically moving across the data in a linear fashion. Linear fashion basically means one after the other in a certain order. When you talk about binary search is a better form of searching because it's more efficient, number one. Number two is that it splits the data in the middle, and then it just forms two entities where it can search on the left side of that and on the right side of the data if the number is lesser or greater respectively. More on binary search in the next couple of questions, but then at this point of time you need to know that there are two types of searching, linear and binary, where linear is a simple form of searching in a set order, either from left to right or right to left, and binary search involves breaking the data into smaller chunks, searching in that, break it again if required, and search, and this can be performed many number of times. Coming to question number 6. How does binary search work? Yes, this would be a very important question which has a very high probability of being asked. Well, binary search, as the name suggests, it's two entities. The first thing you have to always remember when you work with binary search is that it will only work on sorted data. Well, your data either has to be sorted in the ascending order or the descending order compulsorily. And once you have the ordered data, basically you have an array. Let's say you have an array. And basically, if you have to search an element in this particular array, the first thing you'll do is you'll find the middle element of it. If it's an even number, your middle number will be considered as the average of those two numbers. But then if you have an odd number, you will find one singular middle element. So then the data is basically split into the left side and the right side. Now, if you arranged it in the ascending order, let's say we have top 7 elements, 1 2 3 4 5 6 7. 4 will be the middle element, right? So if you're searching for 3, then of course you already know that you don't have to search up and above 4.